Okay, we're working our 45 motor here again. I didn't want to do that. So first thing we did, we measured the valve pocket diameter across here to see what we had. Going across like this. Try to catch an edge somewhere. Where did we measure that at? About in here somewhere. Yeah, we came up with 2065 is our number anyway. That's the number we came up with. The exhaust, we came up with 1-800. That was going across this direction here. Wiggle around until you get what you want. Oh, too much. Popped off the edge. Anyway, it's hard to read. So we got that pocket down to figure out first. So that's all relative to what we're going to cut our head out here. How big is our head here? Did we measure that yet? 2 inch. 2030. See, that's why I didn't weld it up. Because we should be cutting bigger. Okay, next problem is our head gasket. There's a lot of float. Now when you put the head down on here, you can either rotate it this way, or kind of guess in the middle. Because the head bolts are loose in the head here. So there's no alignment dowel pins on the cylinder, so you're using the head bolts. So you want to make this here match up with this undercut. And if you got it oriented the wrong way, you can have a big lip. Next thing is when you rotate the gasket, you can either shroud your breathing area over here, or you can unshroud it by which way you rotate the gasket here. The next problem is when you rotate the gasket, this side of the bore is good. This side over here is overhanging. So we have a lot of float down through here. If you go the other direction, this side here overhang, but we pinch off our flow area over here. So one of the tricks on the racing is you unshroud this area right here to gain flow. You also lose a lot of compression, so the trade-off like everything. So the other way is you're going to float this thing around and center it up and then tighten it on the middle, but you have no way of knowing what that is. So we have to pick a direction. We're going to move our head. So next thing is figure out what's going to happen on the head point when we do all this movement. So now let's put all the head bolts in here. So what's going to happen, we're going to probably wind up cutting this side of the gas way over here to gain clearance. Okay, let me see the other head. Okay, get all our bolts. Now this one, the hex head is going to act like a centering device on this. So this is going to center the gasket up pretty evenly. It's not going to let a lot of float in it. But you can see how we got room to cut around the pocket here pretty easily. So this doesn't really give us the same effect that we were getting before. Yeah, hold on to that. Back red again. Alright. Operator error. Okay, this way the bolt won't dig into the bolt so much. Okay, so now I can move it more like it would be on the head. So it's a matter which way you rotate this, see. No matter what, we're not going to uncover this. So we got to figure out which way we want to rotate things. We're going to cut the head to match whatever the cylinder is because that's how we're going to do it. We just matter which way we want to rotate things. Now our thinnest point for sealing is right here on this edge, right here. So I like to rotate the head so we gain clearance on that part. See how you can gain clearance? We lose clearance. So I prefer doing it that way. If you rotate it this way, you gain a lot more thickness on the head when you cut it. The head's like the gasket, it floats. See, it floats differently in the hole. So I like to rotate the heads the inward direction. Shows you how I do it. So if we do that on this one, we're going to have to trim away this gasket through here to make sure we have room. Because you don't want to overlap like that. Very bad for combustion. You can see how much the gasket's real close here. We have a big gap on this, so we will definitely be cutting this out bigger. Alright, so these are all things you have to kind of play around and think about a little bit. The next thing is we need to get some kind of an idea what's going on around here. So we're going to rotate it this direction. So from there to put it on here somewhere. This area we need to cut away a little bit with the gasket, but not to that line. I do got the wrong head. Yep. I had the wrong head out. Okay, so that's roughly how much cutting can be done. So we're not going to cut that much because the gasket's a lot bigger on the exhaust over here than we need. See over here? So only intake's going to be close. So you can see how close you're going to be on the intake side of things.
Mm-hmm.
So that's just kind of a rough idea. We're going to actually send this up in the mill, and it's going to cut where it's going to want to cut.
And we're gonna come straight across here.
We'll be coming through at an angle. Probably some area, something around in this area here. We'll have a shelf put in here. I'm not sure what angles I'm going to use, but I'll figure out when to use. Stock, it was like straight. Depending on what book you read, they have different angles where they cut these things at different angles through here like this. And, roughly, I go up this and I come up a little bit on this side, I think, and then that's about the angle I cut out, as I recall. But that's going to be a variable number until I figure out what I want to do. For roughly, just for kind of a reference point, just kind of a half-ass one. This here is going to be an angle. So it'll be high here and it'll be all the way down to here. So I go through at an angle like this. when I was playing around before on the flow bench, it liked in my race bike, it always liked being cut through here deeper and leave a nice good angle like this, a nice deep shelf all the way down to here. So even though you lowered the compression by cutting this all out through here, it seemed like it ran better. And usually I make this where it's more straight. So my race bike was more like this. That's what I was doing. But there's so many variations I did over the years, I don't remember which one worked the best because I did every direction you can think of. I even reversed it and tried it. And different heights, different angles, different clearances, you name it, I tried it. All I rewarded doing going slower and slower and slower and slower. Initially you went fast and then it went the other direction badly. And the biggest thing was cutting this port bigger, killed it. That's why we filled your port in. That made it run better. Alright, so these here are supposed to go in there. Any markies front and rear? No markies? So I know we gotta figure out how much we're gonna cut this away here for flow. This here has to be blended all the way across here. I don't want to go cutting too deep downward. That just kills compression. So I'm gonna make like a hump body where it has to flow over a berm like effect. So that'll make it more rounded. And the air is going pretty flat at 30-degree angle. So there's the angle the valve wants to be at. See, there's no cutout over here, so it gives it a good angle there. Deal. That's 30 degrees. So we can come up with that at a 30-degree angle. The flow will be exactly the same seat would be at. If you cut it flat like everybody does, it has to make an abrupt change like this. Here I don't like making abrupt changes. And 45 would have been way the hell up here, seeing that's 45 degree. So this is our seat angle. That is our back cut angle. So we should be running at the back cut angle, which is this much. So we want to cut this at this kind of an angle coming up with a fairly wide radius through here, not a sharp radius. Nice long flat radius here. Making it real blunt and sharp, which is basically making a step. Did not make any power, just killed it because the compression went away. Leaving a nice long tapered up like that seemed to run better. Had more compression. So those are your two angles we're going to worry about. 30, that's probably a 15 or something, because that's what the valve's cut out. So we got to duplicate that angle through here. So we will be cutting this in a little bit, probably by up in this deep we'll be blending. And like I said, cutting on the back side here does help flow somewhat. It sacrifices compression, but it does help a little bit. So being down here at sea level application, I think we'll cut this out. If you're up at high altitude, probably better leave it because you gain compression. Compression is always more important than flow. So, slightly different depending on where you're racing at. So if you're at Bonneville, you leave it all in there. If you're drag racing down here at sea level, you cut it all out. Only problem, you have to have a different motor for each one. Can't do that, so you pick the one you want to do. Alright, so that's how we're going to do all that. So we got to figure out now is we have to get the head cylinder combination in the machine and figure out how we're going to do that. Right now, I don't think we can even put the head on here because we have clearance issues. See what the clearance issue is?
Sitting on something.
It's hitting something, yes. So the first thing I do is figure out how we're going to fix that problem. So the problem is right here on these corners. So it's right in the center here, which in this case is way over here. So this intake is here above the top. So up to about here is where I'm good. So we only have to worry about this area right through here, which I think on this application, where as long as we're not hitting right here in this corner, we should be okay. So we might be hitting on this corner a little bit, I'm not sure. It's close. That's our high spot, see, through here. So I'm going to say we probably cut this corner away with the grinder a little bit. Where's my pen? Right here. Where's my black pen? Somebody stole my black one. Look at these orange. So I think we need to cut this way right here with the grinder. Get that out of the way. Can't see much different change there, is there? Go grab me a brag pen off the top of the workbench back there.
Where do you keep them?
Now see that white label right in front of you, the oil, chemicals, top shelf right in front of you.
Oh, I see, okay.
Thank you. Okay, so I'm going to cut that away. I think this is fine over here because I should be below the surface. So I think I just need to worry about this corner here. Maybe it's hitting. We'll find out here in a minute. And then the exhaust valve is going to be hitting on the whole backside, so all through here we're going to have some issues with hitting. See right through here. That's where most of our intake issues are at. It's about here, from here on. So basically about where the center of the port is here, outward for the valve diameter. So we're not sure where that's going to be to, but somewhere around in this area here, this is all needs to be ground out a little bit through here. Not exactly sure where the valve angle is going to be, but basically that much area. So we go back and hit the grinder right through here real quick, put a bevel in there, and I should be able to put this thing down, maybe. So what I'm going to do for sure right now is I'm going to go ahead and mark this like this. Put it on top of here and see what kind of marks we get. We got paper gasket right here. Now this gives us a false number, but it will allow me to bolt it down. See it raising me above the height of the seat. You have to shorten your head bolts up a little bit too, if yours are long. I think yours are short already, but that's a race bike. I use these for here. These are where I put dowels. But on this application, we're coming off these holes over here. You can see that's how the jig's made.
Mm-hmm.
So I think I have to come off of these four here. Because these other ones aren't going to be in there. They're not going to be there. So which way do you want to rotate this? I think,
That way.
I think we're going to rotate that way?
Yes.
Okay. Get it tight. It's loose until it's tight. Okay, rotate. Exhaust is tight. Intake's not a crankshaft issue. We're not hitting on that, so the intake's not a problem. The exhaust is hitting hard. So what we're going to do after we get this done is I'm going to take this whole assembly and flip it up, put it on top of that jig. I'm going to come over here with some indicators. I'm going to put this center up in the mill. So this is vertical up and down. And we take the head off, take the whole assembly off, put the head back down on the jig and hope it repeats. You're asking a lot. And then we can kind of cut the pockets out here in the head. And hopefully nothing moves, but there's nothing to keep it from moving. That's the problem. I'm dealing with clearances on everything. And there's no better way of doing it unless you dowel it. Even then you have to have it digitized each time you do this. See exactly where the valves are at. Or just go for it and be close enough, which is probably what you wind up doing. It's better to be cut a little bit bigger in the head than be an overlap in the cylinder. So if you have a lip hanging over on this, it's like the gasket sticking over the bore, it's a major problem. If it's cut too big, it doesn't hurt anything. It just lowers compression down. So this does not fit in your head here, this washer.
No, it doesn't. Turn it on.
So you want to put these things upside down on your motor. Yep. So we have to see if your washers, we're using a thick washer I think, so we have to see if they're the same. So we have to make sure that they're put on backwards.
Mm-hmm.
I hate doing that. It looks like crap when they're backwards. Maybe we just tighten them down and not worry about it.
Crush the head, yeah.
Just
Break the
crush the head.
fins.
Yeah, it's only hitting like 10,000, 15,000. I'm sure it'll be fine.
Yeah, they never come out again.
That's alright. They'll wear the fit. I don't even see a mark. Hoping to be at least one mark. Oh, there's a mark.
Yeah.
So it looks like my mark's pretty close.
Yeah.
Okay, so we just cut about a 1/16 thick around that edge. So if I cut to my line, basically I'm golden. And that's about the size it's going to be. When we're all done, it'll be just a little bit bigger. About one line further out than what this is. Okay, I'm going to go back to the grind and we'll do that. That was 3 drops, wasn't it?
Close.
I thought. Well, it's got extra clearance, so I need it.
To use that transmission oil.
I need an airline down there. Way down there.
Oh, wait, it's not on your computer.
Yeah, I only got one airline right now.
What do you got?
Yeah. All
Only
the
a
airlines
bitch.
broken. All the airlines broke within an hour and a half. They started blistering and popping for some reason. Fittings are on order.
Got rid of that oil.
What are we cutting here? I don't remember. Did I ever make a big one? I don't think I ever made a big one. Did I ever make a big tool? I think I did, but I think it broke. Yeah. I need a junk spark plug to make a tool.
There's a broken spark plug.
Yeah, that'll work.
Well, the only thing is it's too small.
Oh.
It's just perfect.
Well, I could do that.
We'll just work around it. We don't need no fancy ass tools around here. That's what I got boring mouths for. Perfect. See how that works? Okay. Oh, I'm digging a hole in my head. I don't think I need to cut that because that was on the back side. But I'm here. Trying to hold it. Got a bunch of fins on the other side, but they're all right, right? Okay, what was our mark on this one? I don't remember. It's a lot more cutting on this one, isn't it? Uh-oh, cutting too deep. I'll come back and weld that all up.
There goes the compression.
It did. Big drop. That's 2 points right there. it's close enough to go do a mock-up. See if it clears. We'll be back. Okay, we've been back and forth a few times on these getting this cut, so we got this one just barely hitting. This one's loose, and I had to loosen this one up about a half a turn to get it so this would turn. This one here, I just loosened it barely. And right now, this one's only hitting right in that little spot right there. Everything else is now clearing all the way around on that one. So just a back and forth process here to get all this done. So we're able to turn it though at least. Alright. Pull that up. What we got here this time. Got it? Got a vibration issue with that bolt. There's some lubricant on the thread. A humming action going there. Now it's got enough rust in there, it's good. Alright. This one's barely hitting all, but it's hitting enough that we're having a problem. We've barely got two little specks. This one's actually close to the other one, but it hits. Alright, so I got two more little grinds to do, and hopefully they'll clear. We'll be back.